Okay, so now we're on to the third part, which is where we're going to find a math model for the cost of a bus ride. Before we do though, let's take a break and add some things to our toolbox. So here's what I want you to put in your toolbox. Um, so at the very back of your notebook, one of the pages said finding math models, right? That was one of our pages at the very back. So these notes at the top you don't really need. You can put those in if you want, but the part I really care about is right here. What I want you to do is sketch a little graph on the y-axis and the x-axis. There's an arrow, that's the coordinate axis, and then you draw a straight line that goes through 0, 0. So what this is just a reminder for us that when we graph data and it looks like this, whatever x and y are, if the line is straight and it goes through 0, 0, then this is what our math model is going to look like. So on the first one we did, we were looking at the length of the shadow and the height of the stick. Now we will never use y and x, okay? We will always replace those with the quantities in our problem. So for our problem, we had the length of the shadow, and instead of x, we had the height of the stick. And we put our slope in that we got from our trend line. So this is just kind of a placeholder, these y's and x's. We will never actually use an actual y or an actual x. We'll put in what they represent. So when you have a line that goes through 0, 0, and it's a straight line when you plot it on the x and y axis, your math model is going to look like this. It's going to be whatever's the y-axis equals the slope times the x-axis. And our conclusion is going to be like this. We're going to say y, whatever that is, so the length of the shadow is directly proportional to the height of the stick. We're going to put in what x and y are. And conclusions are sentences, so we're always going to write them out in English. Okay, so put that in your toolbox so that for the rest of the year when you graph data that you collect and it looks like this, a straight line when you plot it, you'll know what the math model is going to be and you'll know what the conclusion is going to be. So pause the video if you need to get that in your toolbox. Now, another possible result is that our data looks like this. We still have y and x and we get a straight line, but the intercept is not 0. So in that case, the math model is going to look a little different. The math model is going to be y equals m times x plus b. There's going to be an intercept on there. Okay? And if that happens, we cannot say that y is proportional to x. We say y is linearly related to x. All right? So our next example is going to be of a case where this is the kind of math model you're going to get. All right? So what you're going to do is you're going to go back to your lab. This is the one about bus rides. You're going to plot your data, but in this case, it's not going to go through 0, 0. There's going to be an intercept. So your math model is going to include an intercept. So for distance, let's use the variable d. For the cost, let's use the variable c. So your math model, your equation will have c and d in it. So go ahead and see if you can finish this one. And make sure you got those two graphs in your toolbox. And so you'll know what to do with them. And then you'll have them. And then you can go ahead and finish up part C, which is about the bus rides. When you finish that, show it to me. And then you're going to move on to the last one, which is nonlinear models. We'll do 2 of those, okay? All right, so finish bus rides, show me your graph, and then you can move on to the next one, which will also have a video.